All right, so for the next part of this lesson, it's actually lesson 5, part B. Is that what it says at the top? 6, part B? Total new lesson. All right, I would just classify this as a continuation of the last lesson, but you need to be aware of a couple things as you're doing these problems. First of all, when I look at my denominator right now, I have x cubed. Okay? If you see x cubed, you're going to have to break them down. The highest power of your denominators that you're going to work with are either going to be linear, which is a power of x as 1, or it's going to be quadratic, where the highest power is 2. So now when I look at this, I can't use grouping. I only have 3 terms. It's not the most effective way. So what strategy have we learned that we used at the beginning of the unit to break down polynomials into smaller pieces? How do we factor polynomials? What strategy did we use before? You can't complete the square if it's a cube. Grouping is 1, but the problem is we don't have 4 terms right now. We're going to use synthetic division, right? Synthetic division, how do we determine what we synthetically divide by? Plug it in the calculator. Go ahead and do that. Plug it in the calculator. What do you get? I'm sure on these videos it's ironic to hear all of you like slamming around in your bags, like pulling out your calculator. What do you think? Come on, look at the picture. Go to the table. What is 1, 0? 1? 1? You got an error at 1? So 0 in the calculator is 1. Okay, now this is one mistake. Please do not make this on your test. 1, 1, -2, and go. Why is that wrong?
Yeah.
I hear blah, blah, blah. I'm missing which term? The x. Right here, I'm missing the linear term. I need to put a 0 in as a placeholder. Don't ever forget that. That is the number 1 mistake. Number 1. Okay, so then I draw my line, I bring down my 1, I multiply. And notice I get a 0 from my remainder. Yes, sir. For 1? Oh, that's why. You put the whole rational in. We want to find the 0 of the denominator, so I would put y1 in as just the denominator. And that makes sense that you're going to get an error because the error is going to be what? What violates the denominator. So if you do put the whole thing in, you're looking for errors. If you're just putting the denominator in, you're looking for values that exist in the table as zeros. Easy zeros. Okay, good question. All right, fantastic. So now, if I have a 0 of 1, what was its factor form? X minus 1. So I'm going to put that here, x minus 1. What is this 1, 2, 2 stuff? X squared plus 2x plus 2. X squared plus 2x plus 2. So I've taken this purple denominator and turned it into a factored form. Does anyone have a question about that? Because I'm going to erase all of this so that it continues to move down. We're good? We're good. So rather than using traditional factoring, we're using the calculator 0 method. Right? Now, from here, what I would do is I would set up my fractions with my denominator. Does x squared plus 2x plus 2 factor? No, right? It does not factor? 2 and 1 will never give you a 2x for your linear term in the middle with your outer and inner addition. So that tells me I'm going to have an x minus 1 And I'm going to have an x squared plus 2x plus 2 in the other. Now, the reason I changed colors is this. In the previous lesson, all of our denominators had a highest power of 1. They were linear factors. This is an x minus 1, which makes my numerator 1 degree less, which is a constant. I would just say a. But now, I now have this new concept of a denominator that is quadratic. 1 degree less will start with a linear, so now I'm going to say bx plus c. Look at linear and the constant, the decreasing power order. So notice I still have 3 variables to solve for, a, b, and c. This will be a pure number. This could be a quantity. It could end up just being the linear part, or it could just end up being a constant. That is the difference in today's lesson. So now, if I go across the top, I get x squared minus x minus 5 is equal to a times what? What am I missing to get the LCD for a? Right, remember we have all this going on like this, and then we multiply by the LCD. So a is missing x squared plus 2x plus 2. What is bx plus c missing? X minus 1. Okay. It is my suggestion to you, anytime we get to quadratics, where the denominator can't break down any further, and you start having bx plus c, cx plus d, things like that in the numerator, that you go to straight what we call linear combination method. The linear combination method is what I started on the board with earlier today. It looks like number 3 from the last example. So I end up with x squared minus x minus 5. I distribute the a. Ax squared plus 2ax plus 2a. I FOIL the next part, plus bx squared minus bx plus cx minus c. Notice I'm not plugging in any zeros. I know I'm going to need this line of work because I only have 1 0. What is it? What's the only 0 for my denominator that I have? 1. If I plug 1 into here, if I plug 1 in, don't I get 1 minus 1 minus 5 is equal to what? A times 1 plus 2 plus 2, which is 5, plus 0. A is equal to negative 1. So this is a negative 1. I only have 1 0, but I have 3 unknowns. So I'm going to need to do the linear combination method, which is what we were talking about today. Now, let's just take a look here. I have an x squared. I have an x squared. I have an x squared. I have no cx squareds, only a, b, and c. Do I have either a or b? I have a right here. So that might be a good place to start. So I could say 1x squared is equal to negative 1 x squared plus bx squared. What's b equal to? B is 2. So here's a, here's b. So I know this is going to be a 2x. Now I need to solve for c. What do you think for c? Do you think we should use the linears, or do you think we should use the constants? What looks like it's going to be mathematically easier? Probably the constants. So take a look. C by itself is a constant. X, linear, linear, quadratic, constant. There's no x. Linear, and then over here. So now I've got negative 5 is equal to 2 times negative 1 minus c. What is c equal to? Let's see, negative 5 is equal to negative 2 minus c. is equal to 3. C positive, move that to the other side. Yeah? No. Did I solve that too fast? I do enjoy dazzling people with my linear equation solving skills. I mean, I've only been doing them for 40, 30 years. No, that's not quite right. 27 years. Yeah.
So you did that, the green part, like the blue part, right? As the fully factor.
I took this fully multiplied out form, and I decided that I'm going to roll with the constants because it didn't have any B constants in it, like the solving for letter B. Even though I found it and could have plugged it in, it's easier for me to choose the least number of substitution variables. And I got that, so I can come up here and I can put the 3 in. Yes? Yeah? Okay, opportunity. Ask any questions in the world. Totally free, no charge. Yes?
For A, I thought you have to start like by putting the 0 for X.
I did, right here. 1 minus 1 minus 5. I plugged the 1 in. This 1 right here. I just did the work up here.
But wouldn't
1
it be 0?
minus 1. What?
Like wouldn't it be 0?
It is. 1 minus 1 is negative 5
Oh,
is
okay.
equal to 5a. And then that 0 went away, so I divided and got negative 1. Like I solved this linear equation. Good? All right, so the last problem we have in our notes, which I'm going to have to move this. All right, the last problem is going to be the ultimate top of the mountain for as far as we're going to go with these. Notice I have a quadratic in the denominator that is a repeated quadratic factor. Do you have that written in your notes? Repeated quadratic factor. Yes. The fact that this is a quadratic squared matters. And we're going to model off of exactly what we did with linears. Does x squared plus 1 break down? Doesn't factor, right? X squared plus 1? No. So my two denominators are going to be x squared plus 1 plus x squared plus 1 squared. Does that look familiar to what we did with the linears? Yes? The only difference here, is that now my denominators are quadratic, which means my numerators have to be linear. Ax plus b, moving here, cx plus d. So what I would like you to do is, I would like you to try taking 5x cubed minus 3x squared plus 7x minus 3. What is ax plus b missing? Just what? What's this first fraction missing if this is my LCD? X squared plus 1 squared. It's just missing an x squared plus 1. What's the cx plus d missing? Nothing. I want you to take this line of work here, and I want you to multiply it out. And you're going to have to use all linear combination method for all 4 variables. Okay, so in number 2, what I did was I multiplied it out, and I went as far as color coordinating the different degree variables. Take a look. Here they are. So to me, I think the red pops out. Can you tell me what A is? A is 5. So there's your first variable. A is 5.
Oh, yeah.
Yeah, I was thinking about this. I was like, well, you know, if you had some colored pencils, and I was like, boy, that's so 1980. You wouldn't even go through it. Take out your colored pencils. All right, so also I think that B is pretty obvious. B is what? Negative 3. They're the only quadratic terms. So let's make a list. I have A is 5. Great. I have B is negative 3. I don't know, I probably think the green would be easiest, so I can do 7x is equal to ax plus cx, and I know what A is, it's 5. So what's C? 2. And I know right now some of you are going to start to feel a little bad. You're like, oh my gosh, this was so easy. I didn't see this before. But it's the colors. I get it. It's the colored markers. It's the fun. It's B plus D. But I know B over here is -3. So what's D? 0. And then you just go back and you plug everything in. Yes? So my final answer up top here is going to be 5x. This is a -3. And then my C is a 2. And my D is 0, so I don't even have a D value. Now here's a little secret I don't tell you from the beginning. As much as this looked really confusing and hard, if you're good at linear combination, it's faster than the zeros method. It's way faster than the zeros method. And you have less chance for mistakes because the math is a lot simpler. It's just combinations of adding and subtracting. Whereas this method, you have to plug it in, multiply, do mental math, a whole lot of stuff. It's up to you how you choose to do it.